Hello everyone. So in this session, I'm going to look into discretization exercise or binarization. So binarization is a special case of discretization where we're looking into two bins because after all, we need to represent objects with 0 and 1. So simply what we are going to look into in this example, we're going to apply equal width approach and equal frequency approach. Okay, so without further ado, let's go into the exercise and see what it's all about. Okay, so in this exercise, based on the table shown, so let's say we have a data set for 6 objects for 2 features, x1 and x2. And we are interested to build a binarized table version of the attribute x1 only. So we're looking only for x1, considering both approaches, equal width and equal frequency for 2 bins. Now, since it's binarization, so of course it's only for 2 bins anyway, right? But if we are talking about generally, where we have trying to apply discretization, so we may have more than 2 bins. Right, but for binarization, as I said, it's a special case of discretization where we have only looking into 2 bins. Why? Because after all, we're gonna represent the data set with 0 and 1. So let's start looking into the first one. Okay, so let's look into start working on equal width. Now for equal width, what is the idea of equal width? The idea of equal width, let's say if we're talking about a farm, let's say I have a farm and I would like to split this farm into 2 to give to 2 different people, for example. Then if I like, either I can go with equal width or equal frequency. Let's go with equal width. Simply in equal width, for the sake of simplicity, let's say the length of this farm is 100 meter. Okay, so I'm not gonna look into other dimension. Let's say just length. Then since I'm applying equal width, so simply the logical way is just to split up the farm equally based on its length. If it's 100 meter, that means 50 meters go for the first bin, another 50 meters go to the second bin. Right, so this is by equal width. A very simple way. So let's start looking into how to represent. Again, we are looking only into x1. So let's see how we're gonna represent x1. So in this case here is ID, and now we're looking for the range. Now, in order to determine the range, the bin range for each one, again, we have only 2 bins. Simply, we need to know the width or the range of the values that x1 may take. So if we look, the smallest value for x1 is 2. So the smallest value, while the highest value x1 can have among these 6 objects is 10. So very simple. In order to split up, I need to find the split point. So simply I can take 2 plus 10, right, divided by 2. Then I'm going to get the value 6. So based on this, simply I can come here and say, well, the range should start from, of course, the smallest value, which is 2, up to 6, right? And then the second range should start from 6 up to the maximum value, which is 10. Right, so equal width. So here I have 6 units, while here I have another 6, sorry, not 6 units, 4 units, 2 up to 4, right, and 2 up to 4, 6 up to 10. So 4 units. I intentionally kept this value here. I mean, I didn't include anything, simply because I cannot use like this. I cannot close the range like this. If I say this, that means in case if I got a data point where the value of x is 6. Just imagine I got another data point where the value is 6. Then in this case, how can I determine in which bin this data point has to go in? Right, so this is why actually intentionally I kept first this without anything. So now in order to solve the issue so that I don't have a case where a value cannot be determined or actually can be placed into the two bins. So what I can do, either I can use the math notation like this, meaning 6 is excluded, or you may in different way just put here 5.99. So either you can have, let's say, 2 up to 5.99 just to ensure that we are in range where 6 is not included here. Or simply you can do with this. That means any data point that is less than 6, such as 5.999, should go under this bin. Now, since we found the ranges, now our job has become very easy. We have 6 objects, and we are ready to binarize those objects. So now for the first range, let's look into the first value. Sorry, the first object is 10. So where 10 should be located, the first range or second? So absolutely in the second. So again, binarization should represent the object only by 0 or 1. So since it's here, of course, it's not here, 0. How about second object, the value of 2? That means it's located in the first range, but not in the second range, right? So this is 1, this is 0. Third is 8. That means it's here. Fourth is 3, that means it's here. Fifth is here. The sixth object is here. Okay, so notice how 4 objects have ended up in the second bin while only 2 objects ended up in the first bin. And that's fine because we're looking into equal width, not equal frequency. Now, the second example we are looking, or second approach, we are going to look into equal frequency. So we're going to look into equal frequency. So in equal frequency, if going back again to the example we started when we talked about the farms, so rather than splitting up the farms into 2 ranges, equal ranges or equal length, the point is maybe we decided, okay, well, I don't care about the size or the width or let's say the length of the farm, but rather how many trees I have. And I need to split the farm equally into 2 bins where each bin includes the same number of trees, right? So this is the concept for equal width. So let's start again. Look how our table is going to look like. In this case, our binary table. Now the range we're not aware of, right? So far, we don't know. So here we have an ID, but the point is, as I said, we need to have same number of objects goes in the first bin. Okay, likewise, the second bin. Now, since we have 6 objects, that means 3 should go in here and another 3 objects should go in here. So let's start with the small, right? So the range, this one should be the small range. This is the big range. But again, we're not sure what the range should be for the first or second. But we are aware that 3 here, 3 there. So let's start with 2. Well, let me just put the ID for each object. Now let's start with 2 because as I said, this range is going to hold the small values. So here I got 1 object in the first range, right? Now this one 3 is also small, is going to be into the first range, and then finally we have 7 also will go to the first range because again I need 3. Now I got 3, that's it. This is 0, 0, 0. Now for the second range is actually straightforward case. Since object 1 is not located in the first range, so that means should be in the second range. This is 1, this is 0, 1, 0. Now just I need to put the proper range for this one. Since those objects I have determined to put in the first range, then I can just check on them and find the range, the proper range. So this one's going to be starting from 2 up to 7. All right, this represents for the value of 7. Then I can put here 7. Okay, Then the second one is going to start from 8 up to 10. Again, notice we're not looking into equal width. So if you check here how many units we have 5, while here we have 2. Right? But the point is we are looking into same number of objects in each range. Okay, now if you want here, because we have a gap in the range, so probably just you may think this 7.99, we are still fine in that sense. Okay. Yeah, so that's all about equal width and equal frequency for this example. Okay, so I hope now you have a good idea about the difference of equal width and equal frequency on the example of binarization that we have applied earlier. Okay, so that's all. Thank you for watching. See you again in another session.